Hey everyone, welcome back. In the last video, we have seen how to build a knowledge base, how to build a router agent, and how to dynamically route the user question from router agent to domain specific agents. In this video, we will try to understand how to build these specialized agents, which are customer agent, orders agent, and product agent. If you carefully see, all these three agents does the same thing. For example, what customer agent does, this agent selects the right tables and right columns that answers the user question. The same is done by orders agent and also the product agent. So what we do is we will define one LangGraph structure. We will be using the same LangGraph structure as customer agent, as orders agent, and as product agent just by changing the input. So before getting into how to build the skeleton structure of the LangGraph, now first let's see what happens within each of these agents. Again, as discussed in our last video, I'll be using the terms agent and node interchangeably. So let's see this. For example, let's say user has given some question. The question is, give me list of customers from Sao Paulo state that made at least one payment through credit card. So now once this user question is passed into router node, the router node decides that this question can be solved by two agents, customer agent and orders agent. So the user question is routed to both of these agents. So now when you say customer agent, we already know that customer agent is expert only on customers table and seller table. Apart from these two tables, it doesn't know any other table. So the input into the customer agent comes from user question. It also comes from knowledge base. What comes from knowledge base? From knowledge base, we extract the table description of customer table and seller table because this is a customer agent. Based on these two inputs, we have our first node. Both of these inputs come into our sub-question node. So sub-question node it'll try to generate a sub-question from the user question, which can only be answered by these tables. What does this mean? So for example, let's say the sub-question that this node has generated is list of customers along with customer state. So now this question can be solved by the customer table. But this sub-question node did not generate any other sub-question, like, for example, let's say what orders, uh, for which I mean to say how many orders are there for which there is at least one payment made through credit card. This sub-question is not generated because that sub-question cannot be answered by these tables. So that's the reason we will need to generate a sub-question from the user question, which can only be solved by the tables of the specific agent. In addition to generating a sub-question, this node also tries to tell which table will answer that sub-question. So now the output of the sub-question node looks something like this. It is in the form of list of lists. In the sublist, the zeroth index is the sub-question, and the first index is the table that solves the sub-question. So this will be the output of your sub-question node. So now this output will go as an input to another node, which is called as column extract node. What this node does is, for each sub-question generated by the sub-question node, it will try to extract which columns can answer that particular sub-question. For example, this column, list of customers along with customer state, right? We already knew that the answer for this sub-question can be extracted from the customer table. So now which columns will answer this sub-question? So now customer ID column, it will answer list of customers part. Customer state will answer, give the state of the customer part. So both of these questions together will answer this sub-question. So this is what will be the output of our column extract node. So we will do some kind of data processing so that the output of our customer agent will look something like this. So from customer table, customer ID column gives the list of customers. From customer table, customer state column will give the state of the customer. So now let's write this over here. So from customer agent, what is the output? Customer table. It also said that customer ID and customer state helps us to answer the sub question from the user main question, right? So now let's quickly look at a paint over here. So now this is what is exactly extracted by the customer node. It will generate the sub question from the user question that can be solved by specific agent. It will also give the table name that can answer a specific sub question. So now in addition to this, sub question node will also do one more task. What is this task? We'll try to understand while getting into the orders agent. Let's see. Yes. So now the user question is also routed to the orders agent. So now orders agent is specialist only in these tables, only in tables that are related to orders. Let me clear the chat. Yeah. So now again, the user question is routed into the sub question node that is a part of our orders agent. So what sub question node does, it will try to extract different sub question from the user question that can be answered by tables of these agents. So now here, this sub question node generates two sub questions. Order that has payment with credit card. Now this sub question can be answered by this table. There is one more question. There is one more task of the sub question node. Now let's go back to our paint tab. So now one more task of the sub question node is it also identifies if any table can act as a link between any two agents. This is explicitly not a sub question, but it checks if any table can act as a link between two agents, right? What does this mean? Let's go back to our Miro board. Yes. So now this is our actual sub question from the user question. So now this question can be solved by order payments table. If you look at the schema of order payments table, we have something like order ID and other columns are related to payment details, right? On the other hand, what is the output of our customer agent? Output of our customer agent is customer table, customer ID, and customer column. So now if the output of orders agent is just, for example, not also, if it's just order ID and other payment details, there is no way for us to join the columns of orders agent with the columns of customer agent because there is no common column. So that's the reason in addition to extracting the sub question, it also thinks like, do we have any other link with the other agent, right? That's what we have seen over here. In addition to extracting the sub question, it identifies if any table can act as a link between any two agents. So now in this case, orders table acts as a link between order payments and the customer table. So that's the reason it says that a link with customer table based on order ID. So now orders table will help us in this link. So now this will be the output of my sub question node. So this output will go as an input to my column extract node. So now what column extract node does, it will take every sub question generated by the sub question node. It will try to answer which columns will help us extracting the right information. So for example, for this sub question, order that has payment with credit card, right? It identifies two important columns, order ID and payment type, right? So both of these columns help us answering this sub question. And now when it comes to the link, when it comes to the link question, it says that order ID and customer ID from the orders table can act as a link between both of these agents. What are these both agents? Orders agent and customer agent. So now this is how the output of my orders agent will look like. The output is from order payments table, order ID. One second. Yes. From order payments table, order ID and payment type help us to answer a certain part of sub question. And now from orders table, order ID and customer ID will act as a link with the customer table, right? So now this is the output of the orders agent. So now what is the next step? So now, once we get the output from both of these agents, the output looks something like this. This is output of customer agent, this is output of orders agent. So now both of these outputs will go into filter check, right? We will talk about filter check in our next video, right? For now, let's think, how do we build these different agents using Python? Let's go back to our Visual Studio Code. So now customer agent.py file helps us to build these agents. So now at the start of this video, we have discussed that because all these three agents does the same operation. What operation they do? They'll extract the list of important tables and also important columns to answer a specific user question. All the tables does the same job. So what we do is we develop one LangGraph and we use the same LangGraph as our customer agent, as our orders agent, and our product agent, just by changing the inputs, right? Let's see how to do this. So in our last video, we have already seen like when we are developing any LangGraph application, right? Three major things are important. The first thing, having nodes. Second important component is edges. And third important component is nothing but defining the state of the graph that holds the variables across different nodes that can be accessed by different nodes. So now even in this sub-lang graph as well, we will be having all these three components. So now, before actually getting into the script, let's quickly see how our lang graph looks like. This is how we build our graph, right? So now if you carefully see, we have our start node. From the start node, we are establishing a link with the sub question, right? So from the start, we have sub question node. And from sub question node, we have an edge with column extract node, right? So after column extract node, it's just end, right? So this is what we have seen in our Miro board, right? In the agent lang graph, we just have sub question node, we just have column extract node. We have just seen how what happens within each of these nodes. Let's try to represent the same thing in Python. Let me clear this. Great. So now the first thing to define is defining the state of the graph, which holds all the variables that are accessed by my sub-question node and my column extract node. These are the different variables that can be accessed by both of my nodes. User query represents the user question, right? Other variables we'll see in some time. So now this is where I defined my sub-question node. So what is there within the sub-question node? It is taking my user input, right, from my user query of my state, right? So Q is assigned to my user question. Q is my user question. So now let's assume now we are talking about customer agent. So now customer agent only knows about two tables. It knows about customer table. It knows about seller table. That's all, right? So now our table list, when we are defining customer agent, will be customer comma seller. We will be giving this list as LST variable, right? So now we are giving both these inputs. We are giving both these inputs to a different function called as solve underscore subquestion. So solve underscore subquestion will take two arguments. One is the user query argument, and another one is the this list of tables argument. So now let's see what is there within this solve underscore subquestion. So now in the solve underscore subquestion, we are trying to extract the description for each of these tables. From where do we extract the description? We extract the description from our knowledge base, right? So we are loading our knowledge base into a variable called as loaded underscore dictionary. This has the list of descriptions. We've already seen this dictionary in our last videos. So what are we actually doing for the two tables? Because we are talking about customer agent and this list holds two tables. For each of these tables, I'm extracting the dictionary. I'm extracting the description from my loaded underscore dictionary variable. So now I'm sending the user question along with the descriptions of tables, into this function, which is agent underscore sub question function. So this agent underscore sub question function will take these two inputs, right? And it will generate output something like this, which we have already seen in our Miro code, right? So the output of the sub question node will look something like this. It is taking user question. It is also taking table description from the knowledge base of these two tables. And then the output of sub question node will look something like this, right? So now let's see what is there within this chain underscore sub question, right? It is taking two arguments, user question and table description. So now from where I have defined this chain is defined in customer underscore help dot py file. So now this is my chain underscore sub question. It is a simple lang chain. That's all, nothing fancy, right? So I have a template with some prompt, and that prompt I'm sending it to my model. What model I have used here? I have used a chat anthropic sonnet model with temperature 0. So this is the prompt that I have used. In this prompt, I've given two different inputs. I've given my user query as input and table description as my input, right? So now you can just see what I've given in the prompt later. I'll just walk you through few things inside this prompt. I've very clearly mentioned that this is how my output should look like. It has a sub question and the table that answers this sub question. So I've given the output format. I've also very clearly mentioned that think like you are a text to SQL agent. I've also mentioned a table might not answer a sub-question, but adding it might act as a link with another table selected by a different agent, right? This is very important for us. So now, if you just see our orders agent, what it did, rather than just extracting sub-question, it has thought something broader, right? So it also thought like, if I select my orders agent, it will act as a link with the customer's table selected by the other agent, right? So now, why our sub-question node of orders agent has generated this? It is because this is how I prompted my LLM, right? Very important. Just go through this prompt. So now let's go back to our Visual Studio Code to customer agent, right? So our response will be in the form of list of lists where every sublist has a sub-question and a table that answers the sub-question, right? That is what is there in the agent underscore sub-question, right? That's what we are returning our result. So that result is returned to my sub question, and I'm again returning my sub question. So now I'm just saying that table extract. So here I'm just returning table extract dictionary from my sub question node. So my table extract variable will hold list of lists where every sublist has its own sub question and a table that answers that sub question, right? So this table extract is what we have declared over here, right? We have declared it over here. So now let's see the next node as well. So the output of the sub-question node will go as an input to my column extract node. So now what column extract node does, for every sub-question that is generated by my sub-question node, this column extract node will understand which column ID will help us to answer that sub-question. So that's what is done by column extract node, right? So I have defined column extract node as column node over here. So we are just giving two things as input. We are giving sub question, right? We are giving the sub question that is generated by our sub question node. Along with it, we are also giving user question as well. You can just go through what is there within both of these functions. It is pretty straightforward. So now here in my agent underscore column selection, I'm calling something called as chain underscore column extractor, which you can find that in my customer underscore helper file, right? Even here, I explicitly mentioned that your selections will be used as a SQL generation agent. I'm just giving you direction like whatever you generate, just think like a text to SQL agent, right? You can just go through this. So now let's go back to the customer agent. So now my output of the column underscore node will look something like this. It looks something like this, right? So now if you carefully see the input to the sub question node, I have given I have given like this, right? I've just given a list as input to the state of table list. So which is customer and seller. So now if I give customer and seller, this LangGraph will act as a customer agent, right? If I change my this input, if I change my list from customer and seller to, let's say, I give something else as input. Let's say I give this as my input. I give these list of order tables as my input. If I give all the tables as my input to my subquestion node, right? So now this LangGraph will start acting as uh, an orders agent, right? What are we actually doing? We're just taking a user question based on the list of tables that I give. I'm extracting the descriptions of those tables, right? That's what I'm doing. So soon after you change giving customer tables to orders table, right? So now this LangGraph will start acting as an orders agent. Pretty straightforward, right? So now let's go back to our main function. So now remember, this complete LangGraph skeleton is nothing but graph underscore final. I've built this graph. So let's go back to the main function. So in the main function, in the last video, we have seen we have added all these three nodes: customers node, orders node, and product node. So this is where I have defined all the three nodes, right? So what these nodes are taking, these nodes take two things as input: user query and list of tables, right? If you see the table list is nothing but list of tables. I'm just invoking this graph. So now for customer node, I'm considering dstore of customer as my input. What is dstore of customer? We have defined dstore over here. Dstore of customer is the list of customer tables, right? For orders node, along with the user question, I'm giving list of orders table as input, which is dstore of orders. Dstore of orders mean all these orders table. So likewise for product agent, I'm giving all the product list of product tables as an input to my graph underscore final. So it can act as a product agent. So this is how we define one LangGraph as an agent skeleton, and we will be using this LangGraph as customer agent, orders agent, and product agent just by changing inputs, right? So I think pretty much that's it for this video. In the next video, what we do is we'll try to extract the outputs of each of these agents and see what is there within the filter check. See you next video. Bye.